Hi, this video is a submission to the ChronoVideo competition for the 2018 SRBR meeting. I want to explain through this video an interesting and mysterious but less discussed topic in classical chronobiology, that is phase singularities. Given that 5 minutes is too little to understand phase singularities in depth, this video will attempt to just illustrate the general concept and refer the curious watcher to two books that may be helpful for further reading. We'll start by asking, what is a phase singularity? To answer this, let us first perform a thought experiment. Imagine that there are people with good calibrated watches standing at different longitudes along the equator. As a consequence of their location, each person has a different local time on their watches. Now imagine that each of these people start moving towards the North Pole at the same speed. Notice here the clocks moving along the longitude at the same pace. All of them are obviously expected to reach the pole after the exactly same number of absolute hours. Assuming that all of them started at the same time, which is of course different according to each of their watches, when they reach the pole, all of them will have different times on their watches. Now this is the curious part. Which one of these times are correct and which ones are not? In some sense, all their watches are indeed correct, but all of them show different times. This ambiguity in the definition of phase is what is referred to as phase singularity. In this figure, you have phase along the x-axis and a biological variable along the y-axis which oscillates. A stimulus of specific strength administered at a specific phase abolishes rhythmicity in the biological variable. This is the biological manifestation of singularity. Search for singularity in biological systems has yielded results in the kalanchoe flowers' petal movement rhythms, as can be seen in this example. The petal closing and opening is rhythmic, but a stimulus presented at a specific phase abolished the petal movement rhythm, thereby indicating that the clock responsible for this rhythm has been driven to singularity. Similar results have been found for the Drosophila eclosion rhythm in Chlamydomonas dinoflagellates and Siberian hamsters, to name a few. It is thought that this singularity could be mechanistically brought about by the reduction in the amplitude of the mRNA oscillation of the core clock machinery. So why is singularity important at all? Apart from historical reasons and academic interest, achieving singularity using a stimulus and recovering rhythms after singularity is evidence of the stimulus affecting the core clock machinery without actually killing it or affecting other components such as the parameter of the clock or the output of the clock. This gives the experimenter an idea of the nature of the core clock and what stimuli it responds to. More importantly, if one can reliably identify phases at which stimuli can drive a clock to singularity, then it is possible to block such phases of the oscillation from stimulus that may cause abolishment of rhythms, thereby sustaining essential physiological rhythms. Thanks for watching this short video on singularity. Here are the two books that I had mentioned in the beginning. Hope you enjoyed the video.